Good morning slash evening. Um, my name is Trevon, and I will be the next speaker giving my presentation on firewalls. Essentially, the motivation, the idea is deconstructing the idea of firewalls down to a way that, the motivation for some of my research makes sense. Um, so who am I? I'm a current graduate student at UNC Charlotte. Um, I'm in my fourth year of my PhD program, and I am, a lifelong lurker. I enjoy reading hacker news, blog posts, trying to build a better habit of reading papers, going into the world of academia. But at the heart of who I am is a hacker, uh, and I am an active, I guess you could say current active member of the 49th. I was a lot more active when I was in undergrad, but now I just kind of um, oversee or provide guidance for the younger um, class. So, without further ado, let's get into this talk. So, what is a firewall? I think everyone kind of has an idea of what a firewall is, but for the general um, understanding of what we're going to be talking about, a firewall is just something that simply sits at either a perimeter or um, some type of boundary in your network and filters out events or things that you don't necessarily want to have in your environment. Um, there are a lot of different types of firewalls. There's not just one type of firewall. There's the rudimentary packet filter. I say it's rudimentary because every firewall is a packet filter, um, but the packet filter does not encapsulate every type of firewall. And this essentially what this does is analyzes packets as they come through the network or pass through the firewall itself, and it takes off headers from these network packets and kind of does a comparison against these set of rules. So, in headers for typical network packets, you have the destination source address and then the destination source IP or port, and that's helpful for filtering. Then there's stateful firewall. So packet filter, the rudimentary packet filters, you can think of them as like a stateless system. They're using access control lists. They're not storing state. They're doing filtering. Stateful firewalls, on the other hand, are, as the name kind of alludes to, capturing state in some way. And this kind of allows you to do some filtering on the application layer, where you can detect man-in-the-middle attacks, uh, most times, detect DOS attacks most times, and detect and filter out unauthorized access. There's more, things that you can do with stateful firewalls, but those are kind of some general ideas that you can think about. Proxy-based firewalls are essentially firewalls that are having traffic routed through them, so they're not necessarily on the boundary of a network, but they are in some place. They could be in a cloud, and you're just routing host-based host-based network packets through that proxy-based firewall before forwarding to whoever it is attempting to go. And then there's I say a buzzword, but then there's what all or every firewall vendor says their firewall is, this next generation firewall, which is this big suite of utility, which includes intrusion detection systems, deep packet inspection, and some type of application awareness. I think most people who are aware of next generation firewalls know that you have limited bandwidth when you use one of these, appliances, because they're doing deep packet inspection. They can't necessarily, give you 1 gig of throughput and still do packet inspection to provide you that security. So all these systems provide some balance between accessibility and security. My personal favorite firewall idea is the distributed firewall. So this is not a necessarily new idea, but the idea is to provide some type of appliance or solution that does filtering in the east to west traffic flow. So this is not, I guess this is different from, the traditional way of thinking about firewalls that filters out the bad people from the internet coming into your network, because it is filtering out, for example, in enterprises, If you have an attacker who has a foothold in the environment, you have now the ability to filter out detected packets. If you have the ability to detect, the attacker having a foothold in the first place, you can filter out those packets as they try to traverse your network or move laterally in your network. So it provides an additional layer of security and complements, the traditional firewall that sits at the edge of your network. So this is also, not something that you would typically see in a home network because, the home network for most people, I guess for normal people, I would say, it's just a flat network. They don't have, some crazy network solutions where they have multiple VLANs or, multiple NAT networks. This is just, um, this is taking into consideration your traffic is traversing multiple places in the network. So there's a lot of different types of implementations of distributed firewalls. There's the host-based solution, and you can kind of say LinkedIn's distributed firewalls of this flavor. They're trying to, do some configuration of the host-based firewall, which is like on your end devices. You can think Windows firewall configuration. You can think Linux host firewall configuration. Then there's the more, I guess, flavor that I'm talking about is the network-based, device-based firewall. So this is using network switches or having appliances distributed in the network doing this filtering. Let me see. Okay, no questions. All right, so let's just recap some of these, ideas. All firewalls filter packets, but the specific features are not all the same. They're all specific to their use case. So if you go kind of like a layer down into filtering packets, like what, I guess like how would you filter packets? What does filtering packets look like? There are, I guess like these are 3 examples, Linux-based examples for implementing packet filtering. We could just start with libpcap because libpcap is kind of preceded by the rewrite of TCP dump. I guess not preceded, but TCP dump kind of replaces libpcap. But libpcap is a packet filter that uses a filtering mechanism that's based on different kind of like qualifiers, you could say. And so it can filter based on type, which is like the idea of filtering based on host, based on networks, based on port or port ranges, and also kind of destination, like filtering out source to destination or destination to source, and a wide variety of protocols. Then you have the Berkeley packet filter, which is not new. The eBPF extension to the Berkeley packet filter specification is what is the more recent novelty that has led to the hotness in BPF recently. But this is just BPF allows you to create these sandbox programs that live directly in kernel space, which gives you the benefit of being able to process packets inline and not necessarily have to go to application space, which gives you a very good performance in terms of networking. It also gives you the benefit of observability, being able to trace different events in your system. It's really good. NetFilter is also another packet filter, I guess, or a way of filtering packets. And I guess a popular implementation of NetFilter is IP tables, and I believe NetFilter works sequentially in its logic. So we went kind of like a little low in terms of like filtering out specific packets, right? But what are a higher level of abstractions when it comes to networking that enables kind of these ability to filter out packets, which is in a way, packet programmability. And there's this idea of software-defined networking, which isn't necessarily a new idea, which, the motivation of software-defined networking is to increase the programmability of your network environment. And to accomplish this, open flow software-defined networking came out, I believe, in 2011 from a lab in Stanford. We wrote a paper about how to decouple the control and data plane using a protocol called OpenFlow, which basically allows you to have a global view of the network routes, not necessarily replacing, but substituting the need for routers, and then allowing you to have control of switches directly. Um, Open vSwitch is this virtual switch, that in Linux land, you see a lot of development with the data plane development kit, um, which is managed by the Linux Foundation. And just coupling these two ideas, there's been a lot of development and research. Also, leveraging eBPF to how do you programmatically, um, control how packets are handled within a network. And so this is kind of like the level of abstraction in the network where you can kind of have your own custom solutions. So what is the data plane? I mentioned it a couple of times. The data plane is essentially resides on switches, and it's mainly responsible for forwarding packets. So you can just think of, a switch doesn't necessarily know where everything is, right? Because routers are communicating to switches where packets should flow to get to a specific source. And switches are only focused on routing packets. So that the routing function is really fast because there is no, I just got this packet, I need to query, some application or the router always, because there's a flow installed on switches so that it knows like, oh, this is where I need to go. I'm flowing directly to, or this packet is going to be forwarded directly where this flow is kind of telling me. And that data path, the data path in the data plane is that pipeline of, processing these packets. And so the data path is interesting because you can introduce whatever kind of functionality or features that you want to inside of there that would be, helpful for developing a distributed firewall. But the question is this programmable? Can we program this directly for, motivations being security, improving security? And the answer is yes. There's a couple of solutions, eBPF we've mentioned, but there's a solution P4, which, complementary, or I shouldn't say complementary, but at the same time, there was another solution that came out called POF, which is trying to extend OpenFlow, because OpenFlow doesn't necessarily have the ability to program the data plane directly. But P4 allows you to create your own kind of packet processing pipeline from scratch, or you can use their model, their virtual switch model. But they have this architecture that you can use to develop, how packets are processed, and then you can basically compile bindings to your program to basically interact with the program, similar to what you can do with eBPF actually. And then there's another kind of open source solution called VPP. VDIO is their website, and VPP is just vector packet processor, and it is another data plane solution for achieving this packet programmability environment that is so interesting. So how can we put all of these interesting ideas together into something that reduces the cost of security and potentially makes our environments more secure? So that, hacker speak, let's just build a janky next generation firewall. So I guess we talked about what a next generation firewall is previously. So what are the kind of components that we would need to put together to create something like this? We can leverage an intrusion detection system because there's a bunch of different open source intrusion detection systems out there that we can use. So for example, snort Suricata, we just need a listener environment that we can forward packets to. Okay, check. How can we forward packets? Well, we just introduced this really cool tool called eBPF, which allows us to write programs that are sandboxed in the kernel, and they can attach themselves directly to devices or device drivers. So with eBPF, we can clone and forward and also filter packets inline, which means that we have a really fast packet filtering. I guess complementary to that idea, this can be kind of extended further to using P4 to do something similar if we want to scale to larger networks. And then the point of integration, for simplicity, we can just use a Python program to compile, I guess not to compile, but to use our eBPF bindings or P4 bindings to basically control the different filter tables that we have installed on switches or in our environment. So here's an example of a very simple eBPF packet filter. I was going to try to demo, but I've not had any success demoing, so I'll just drop a GitHub repo with this code source once I verify that all the components work in a Docker environment. But essentially, in this very brief code snippet, we just have it's a C code for basically extracting the source IP from a packet directly on the device, and then essentially checking, is this IP within a table? If yes, we're going to drop the packet. If not, we're going to continue processing the packet by passing it up the stack in the kernel and whatever the packet's being used for, whatever program's communicating or using that packet or using that TCP communication session, we'll be able to continue doing that. So in Python, if we wanted to, directly be able to update what's it called, the table that's filtering, we would basically specify what our compiled BPF program is, the interface that we want to bind to, and then essentially we would bind to it with the second provided function. Okay, so hopping out of the weeds, of code, what are more powerful solutions that enterprises might want to use instead of creating janky network or next generation firewalls? There's a couple of different solutions that are Kubernetes cloud native based. There's Cilium, Calico, and Falco, and these are all eBPF inspired solutions that leverage eBPF inside of a Kubernetes environment to provide you with increased observability, but also the ability to enforce network security policies in a very effective and efficient way. There's also a really cool blog post posted by Cloudflare, where Cloudflare is describing how they're using eBPF to basically have their firewall solution. So this comes to the motivation, why I even do this. And this is kind of some of my research motivation with, the ability to programmatically and efficiently update and push firewalls in a way that you aren't necessarily, spending money for proprietary solutions and can be extended, whenever you want to extend your program. This basically highlights a space that has the benefit to allow for network environments to be more agile and secure, but also it has the potential to remove the low-hanging fruit of having to manually, track down network alerts to make sure that your environment basically reflects you stop that network alert that you had saw. Now, there are, a couple of things that you would want to consider. You would want to consider, is this a false alarm? One, are we verifiably being able to filter out things like packets or filter out alerts in a way that doesn't disrupt services? That would be a very big, question that you would want to ask. But the goal of this work is, to be an open source solution to provide a low cost solution for people to be able to secure the networks, especially when they can't afford security solutions, but also to provide a solution that is integrated by default with open source products. So those are kind of the ideas of this research application. So I guess in kind of conclusion, there's some very good resources on eBPF. The Linux Weekly news article provides, they have extensive articles on eBPF written by a variety of different authors. And then the BCC GitHub has a lot of examples of eBPF programs specifically for observability or Linux networking. I believe Sysmon, I saw it, I resaw it today, but I saw that Sysmon got ported to Linux with the BPF. And then Brendan Gregg, he used to work at Netflix. I don't know where he went now, but he does a lot of really good eBPF introductory posts. He has a book about eBPF. I guess On the inverse of um, using BPF for security, there is offensive eBPF. There's a DEF CON talk, I believe, given 2 or 3 years ago that explained how you can use the BPF for very bad things. And I believe actually a lot of people are using eBPF for very bad things. So that is a very interesting space if you are, a penetration tester who, lives in Linux environments, cloud environments, etc. So some takeaways, hopefully, that you have from my talks. My talk is, firewalls can be approachable. There's not just one type of firewall. There's, many types of solutions that you can use, and having an understanding of firewall architecture and how it applies to your network can provide you with, a deeper understanding in a more secure environment. And then data plan programmability. Does it lead to more affordable solutions potentially? Trying to find out if that is the case. I guess I'm trying to find out if that's the case. So you can find me around the web. I should have verified it. This is actually my Mastodon, but I believe I'm on InfoSec Exchange at that handle. I'm also on Twitter at that handle. I don't really post a lot. Well, neither actually. I think I just retweet, but I will post slides and the GitHub link whenever um, I check that it's complete. And then this is my website if you want to reach out to me at any time. So that's all that I have. I don't think I have a question slide, but are there any questions? Okay, so from YouTube, have you seen strange behavior in Mac OS and BPF within newer features? So, have I seen any strange behavior in Mac? I mean, I have not personally seen any strange behavior in Mac, but I know I- the name of the researcher in his website escaped me. But he was talking about, I guess the people who do Little Snitch um, were basically describing kind of some of the new features and how Apple's core features are bypassing their own security mechanisms, which is quite interesting. So, the implications of that are interesting. Um, but have I personally seen any weird behavior? I have not. Um, but I do like the new features. It seems that the new features, depending on how you're, trying to secure your system, uh, they don't always work. For example, like the limit IP tracking or hide my IP if you're using DNS crypt or like a Raspberry Pi hole to filter out DNS traffic, and you happen to include one of Apple's tracking servers, then it doesn't work, which is interesting. Oh yeah, Apple's feature sidestepping. Yeah, I think there was a blog post by I don't let me see. Yeah, I'm not gonna even try to search it, but the creators of Little Snitch, they had a blog post about Apple's feature sidestepping PPF, which was quite interesting when it came out. I think they were actually the first people who caught that. John so maybe you said this, but what was your favorite part of doing this research? I mean, it's still research in progress. It's not done. What's been my favorite part? I mean, I think one thing that I have enjoyed that is also frustrating is, the deeper that you go into research, the more that you realize like there's, a lot of other places that you have yet to explore or can explore. And I feel like the this research is kind of like one of those areas where there's a lot of different ways that could go with it, but trying to, you know, come up with an idea of like what can I provide as research that not only, doesn't increase overhead of security systems, because I feel like there's this stigma where it's like, oh, security systems make my computer slow or it makes my network slow. Like, how can you improve the security of network systems without increasing the overhead? Like that has been like an interesting, or I guess one of my more favorite areas of kind of exploring. Okay. Well, if there is no more questions, I'm going to go ahead and stop streaming. Um, yes, do you plan on doing more blog content or do you potentially will I implement this in my home lab? Probably not. I mean, I guess we'll see. Um, yeah. I mean, one of the big, one of the big gateways of entry currently and, using something like P4 is uh, Barefoot Labs, who created P4, eventually got acquired by Intel, and they now create, proprietary P4 switches, P4 enabled switches, and getting one of those things is you gotta have a business. Is what I'll say. So, um, but you could create your own solutions, right? I'm sure you could design your own risk architecture for a very cheap switch that uses P4. And I think that's actually something that I am very interested in. Designing very cheap um, hardware solutions that you could deploy stuff like this to you know provide a true next generation of firewall that democratizes or you know I guess yeah democratizes how people interact with their own firewall solutions. So it would be cool to have um, something like that. And then I guess if I like any ideas that I have that I feel comfortable sharing that I don't feel like are dumb, I'll write a blog about and I'll tweet about. But I guess till then, eh, I'll probably keep them in my head until they are more polished.